Yes, started. Did it? Okay, started. Okay, so now you see on the slide here there are 5 statements. Okay, and you see some missing parts of the statements, and in these missing parts you will write 1, 2, or 3 words. That's it. Okay, not more than 3 words will come in these blanks. Okay, so and they are related to the previous topic which we covered on Tuesday. So the statements are in front of you. You can start from any statement. You don't have to go in any order. So if you feel that you know the answer to statement number 4, you can write it in the chat or open your mic and tell it to me. Okay, so there is no order required here. You just try to find out what is the missing part of the statement. Okay, any order is acceptable. Okay, so statement number 1, specialized counting studies are focused on trips from what? Number 2, postcard, license plate, interview studies are methods of which studies? Number 3, trips starting and ending in the same zone are known as what? Number 4, volumes are taken from the field for region destination studies to adjust the trips in the dash. Number 5, number of samples depends upon people's willingness to send the responses in which method. Okay, so you need to write down the name of the method here. Okay, so the floor is open. Anyone who wants to? Some answers have started coming, which is good. Same zone, intrazonal trips, very good, fine. Number 2, not travel studies, it's wrong. Number 1, entire area, Haneen, you are right. Okay. Last one, postcard method, right. Okay, so we have answers to this statement. Intrazonal trips starting and ending at the same zone are known as intrazonal trips. Number 1 is area, which is also fine. It's correct. Specialized counting studies are focused on trips from an area. Okay. Number 5, number of samples depends upon people's willingness to send the responses in postcard method. Postcard method. So you have to rely on the people to send you back the postcards. Okay. So now we are left with number 2 and number 4. Number 2 should also be easy. Number 2 and number 4. For number 2, travel study is not the right answer. For number 2, yes. Volume studies, specialized counting studies, I can accept it, but it's not the exact answer I'm looking for. The exact answer is something else. Can you be more specific for number 2? Volume, travel, even travel, okay, fine. Travel studies, volume studies, specialized counting studies, all can be correct, but yeah, now you got it. Okay, origin destination counts. Yeah, origin destination counts. Not cotton counts, origin destination counts. Origin destination counts, origin destination studies is the correct response. Okay, for number 2, postcard, license plate, interview studies are for origin destination counts. Number 4, now only thing left is number 4. Volumes are taken from the field for origin destination studies to adjust the number of trips in what? Where are these trips which we are trying to adjust? Where are they written where we are trying to adjust them? Okay, who wants to try number 4? It is showing number 1, I don't know why. But number of trips in the zone, okay. Close enough, yeah. Anyone else wants to guess? Zone to zone, okay. Coming closer, okay. Again, they are somewhat correct answers, okay. The answers which state, okay. Okay, let me help you out here. The exact answer, coverage coins. Okay, let me help you out here. The exact answer is origin destination table or origin destination matrix. This is the exact answer. Okay, this is what I was looking for. Origin destination matrix or origin destination table. Okay, so you can see in many statements there were more than one correct answer. You gave those correct answers. Okay, and there was another one as well. So this helps us in thinking what we have done earlier. Okay, the only purpose was that. Okay, so well done, well done. You did good. So even people remembered coverage counts and state-wide counting programs and so on and so forth. So which is good. Okay, so purpose fulfilled. Moving on. Okay, so we were discussing origin destination counts earlier. Okay, and I showed you this matrix. So you did some survey or study, you found some number of trips between origin destinations, different origin destinations. You prepared this matrix, you find out the summation for each origin and each destination. Okay, and you have collected data from the field to find out the actual number of vehicles entering and leaving the area, and you write it in front of the or corresponding to the particular column or row. Okay, so the volume is entering in zone 1, you will write it in front of destination 1. If the volume is leaving zone 1, you will write it at the bottom of origin 1, and so on and so forth. Now I need to, the numbers which I have counted in the field are accurate. I need to adjust the numbers in the matrix, okay, so that they become equal. Now, to adjust it, first of all, I will calculate a ratio or a factor. That ratio or factor will be for volume and the number of trips which you have as summation from the matrix. So volume upon number of trips. For each row and column, you will calculate this ratio or this factor. Okay, so for example, for the first row, it will be 250 upon 95. Second row, 310 upon 106. First column, 210 upon 88. Second column, 200 upon 99, and so on. So for each row and column, you will calculate these factors or ratios. Now, how do I apply these ratios to the numbers in the matrix? How do I change the numbers in the matrix according to these ratios? I will multiply the number with the average of its factors. Okay, so for example, you are trying to adjust number 50, which is in the first row and first column. Okay, so you will multiply 50 with the average of factors for first row and column. Okay, let's say you want to adjust 10, which is second row and first column. So you will multiply with the ratio with the factors of second row and first column, with the average of the ratios of the second row and first column. Okay, it is written here. Okay, so the ratios which I'm asking you to calculate is volume upon number of trips for each row and column. So for the column, it will be a summation of trips in that column, and for row, it will be a summation of trips in that row. And volume of that row and volume of that column, and you divide them and you get the ratio for each row and column. Then if you want to adjust the number of trips for, let's say, ith row and jth column, you will multiply with the average of the factors for the ith row and the jth column. Okay, so like I said, if I is 1, then you will multiply, then f will be for the first row, and if j is 2, then f will this one will be for the second column. Okay, so you multiply with the average of the factors for its row and column. Okay, let us do it. Let us do a sample of analysis, a sample, because if you do for the entire matrix, it will take a lot of time and it's repetitive. So if you can do it for a few values, you can do it for all values. Okay. Now you see in this matrix, they have calculated the ratios for each row and column. So 250 upon 95 is 2.63, 310 upon 106 is 2.92. Similarly, 210 upon 88 is 2.39, 200 upon 99 is 2.02, and so on and so forth. Okay. So for each row and column, I have these factors. Now let us see. I will just do a sample of calculation for the first row. Okay. Let me go to the notebook. A good thing about having a slow system is that you can enjoy your coffee and you can check your messages during the class. So like I said, I will only do it for one row. So I don't need to make a large table here. Okay, the first value in the matrix is 50. And the factor for the first row and first column is 2.63 and 2.39. So 50 multiplied by average of 2.63 is 2.39. Okay, and you give me this value. Similarly, the second one is 8. The factor is 2.63 and 2.02. Give me this value. Okay, the third one is 20, then I have 17. The factor for row is the same. Factor for column, I will check 3.35, 2. Okay, give me this value. Give me these values. $157. Can you recheck it? 2.39. Sorry. So this is my mistake. This is 2.39, not 2.30. 2.39. Please recalculate the value. $125 or 126. Okay, you can round off the values. Plus minus 1 will not create an issue here. Okay, next one. Give me the other values. Okay, like I said, round off the values. Don't need to keep the decimal places. And if you do plus minus 1 here and there, it's not a big issue. Okay, last one. 63. Okay, great. In the same manner, you will do it for all the rows. Okay, you will do it for all the rows. Okay, so I hope you understood. Now, once you have done it for all the rows, the matrix has completely changed. With the new matrix, now you will recalculate the summations of the rows and columns, and you will recalculate the ratios, the F values. Okay, so this is a new matrix now. So as I said, if you see some numbers plus minus 1 here and there, it's not a big issue. Okay, focus on the procedure here. The procedure is once you have calculated all the numbers, once you have adjusted all the numbers in the matrix, you will recalculate the summation of rows and columns. So you see the T values are recalculated. Okay, but the volumes from the field cannot change because these are values which came from the field, so they will not change. The V values will not change. The T values will change because you have changed the numbers in the matrix. Now with the new T values, you will recalculate the F factors, the ratios. Okay, so for the first row, you will now do 250 upon 267, then 310 upon 292. Similarly for the columns, 210 upon 232, 200 upon 251, and you can see the answers here. So the new factors are here. Now tell me, what is the ideal value of F? What is an ideal value of F? What am I trying to achieve? Okay, so I started by calculating the value of F, and I'm telling you I will end at the calculation of F values. What F value I'm trying to achieve by doing these calculations? What is the ideal value of F? Tell me. The ratio of trips from the matrix and volume from the field. What is the ideal value? No, 0. Can you have 0? Can you have an F value of 0? Never. 1. Yes. Thank you. Yes, you are trying to make the factor 1. Okay, all of you are correct. 1. So the ideal value of the F is 1. Okay, and it will only come if the trips from the matrix is equal to the volume from the field. Okay, this is the ideal value. Did we achieve the ideal value for any of the rows and columns? The answer is no. You can see all the F values are either less than 1 or more than 1. None of them is equal to 1. Okay. Now, if you try to make all of them equal to 1, it will take a very long time. Okay, it will take a lot of iterations. It will take a very long time. Okay, so we are settling ourselves to a range of F values. So if all the F values, if you do the adjustment of the matrix and you get all the F values from 0.9 to 1.1, this is where we can stop. So if all the F values, the new F values after doing the adjustments, are between 0.9 and 1.1, this is our stop. Okay, at this point we can stop. No further calculations required. Okay, so the factors, all the factors must be in this range. We are trying to make them 1, but making all of them exactly 1 will take a lot of time. So that is not practical. We are settling ourselves to a range which is 0.9 to 1.1. Now, if you look at the matrix and the new F values, you see, let us look at the rows. Okay, first F value in the range, second F value in the range, third F value 0.87, not in the range. Okay, it's not in the range. Okay, next one, last row, again the value is in the range. Okay, now come to the columns. First F value barely in the range, second F value not in the range at all, third F value comfortably in the range, last F value for the last column out of the range by a huge margin again. Okay, so now so we had 8 factors. Out of 8, 3 are out of the range. Now listen to the rule. The rule is, even if one value is out of the range, you will redo the entire process with the new values. You will redo the entire process of adjustment with the new values, even if one F value is out of the range. Okay, why is that? Because when you change one value, it affects the row and the column both. So there is no possibility that you can change one value and it will have no effect on the other F values. Okay, so that's why either you change the entire matrix or you don't change at all. And the rule is, even if one value of f is out of the range, you need to change the entire matrix. Okay, so the same calculation will be repeated with the new values of trips and with the new values of f. So again, I will do the calculation for the first row just to explain the point. Okay, so instead of 50, I have the new trips now. 125, I'm just taking these numbers so that it will be easier for us to cross-check the answers. 0.9. You will give me this value. Okay, this one is 19. Oh, sorry, 0.94. 8. $115. Then I have 16. Okay. 16, 17, doesn't matter. Okay, then 60. Then I have 66. Okay, so the point to be noted is every new iteration, the trips and the factors should be taken from the last one. Okay, not the first one, the last one. Okay, so you can see the trips. I've taken the trips from the last matrix and the factors also from the last matrix which I have. Okay, another important thing which I myself noted today. I noticed this factor today. I've been teaching this course for so long, but I noted this important point today. You see in column number 3, the initial number which you are trying to adjust was 60, and the final number is also 60. So that means that this particular cell did not need any correction. Okay, so there is a self-compensating mechanism in these calculations, so that if a particular number of trips does not need any correction, then it will not be corrected. Okay, so you can see in the third column 60 remains 60. Okay, so if you were worried that this number is very close to the actual volume I have in the field and the new iteration may destroy the closeness, it will not happen. Okay, be sure about it. If the trips do not need any change, it will not change. Okay. Yeah, the factors have not reached 1, but I told you we are not trying to reach 1 now. We are trying to make them into the range, which is 0.9 and 1.1. So even if in the last iteration where I will stop the calculation, if none of them is 1, it's still fine. We are just trying to make it between 0.9 and 1.1. Yes, it is possible. It will take a lot of time. That's what I'm saying. It is possible. Mathematically, it is possible. So if you want, you can prepare a MATLAB program which can keep on doing the iteration for you. And in the end, you will get 1, no problem. Okay. But manually, like for the sake of the class, we are not trying to make it 1. Okay. So you do after the second iteration, the matrix will look like this. Okay, the summations of the values are these, the new summations, and the new factors are these. Okay, and again we apply the same range to all the factors. Are they coming in the range? So if you look at the rows, we have all the factors in the range. All the factors are between 0.9 and 1.1. If you look at the columns, I think you cannot see it. Now, if you look at the columns, one of the factors out of the range. For second column, the factors out of the range. All the other factors are in the range. Like I said earlier, the rule is either you change the complete matrix or you don't change it all. Okay, so either all the factors are in the range or otherwise you have to change. Okay, in this case, one factor is out of the range. So because of this one factor, I have to redo the calculation for the entire matrix using the new values now. So the TRIFs which you are trying to change are these 116, 16, 60, 66, 26, and so on. And the factors which you will use are these 0.97, 1.08, 0.92, 0.97, 0.87, 1.04, and so on. Okay, so with the new values of factors and TRIFs, you will redo the calculation. I hope now you have an idea how to do it. And this is the final matrix. Okay, this is the final matrix now. Okay, and with the final matrix, you will do the summations. Okay. Okay, with the final matrix, you will redo the summations, you will recalculate the factors, and you will check it with the range again. So you can see the factors are all the rows, they were already in the range, so still in the range. For the column, second column was out of the range, now it has come in the range as well. So all factors are in the range, this is my final matrix. Okay, all factors are in the range, so this is my final matrix. Okay, one thing to be noted, with each iteration, the factors will be coming closer to 1. With each iteration, the factors will be coming closer to 1. So if you see, for example, you did the first iteration and the second iteration, and you notice that some of the factors are not coming closer to 1. That means you made a mistake in your calculation. So this particular logic will serve as a check for you. You want to check your calculation. So you made a mistake in the first iteration. So the numbers are wrong. So they will remain wrong till the last iteration. So with every iteration, you can check if the numbers are making sense or not. Okay, and what is the check? With every iteration, each of the factors, each and every one of the factors will be getting closer to 1. Even if they are not becoming 1, they will be getting closer to 1 with each iteration. Let me show it to you. So focus on the factor for the first row. Just an example, you can, in your own time, you can check all the other factors as well. So one thing is for sure, when you get the initial values from the survey and when you put the volumes from the field, the first matrix will never have factors in the range. The first matrix will never have factors in the range because there is no way in which the numbers from the survey are close to the volume from the field. There is no way in doing that. Okay. So for the first iteration, the factors will always be out of the range. Okay. So in this iteration, you see the first row has a factor 2.63. Okay, way out of the range, no problem. We perform the calculation. Then we move on. In the second iteration, you see from 2.63, it's 0.94. It's in the range. Okay, very good. Okay, all there were many factors which came in the range. So this factor became 0.94. I had to perform another iteration not because of this factor. This factor is in the range, right? But still, with every iteration, even this factor will become better. So the factors which were out of the range are becoming better, but even the factors which are in the range are becoming better. Becoming better means what? They are coming close to 1. They are coming closer to 1. So you see, next iteration from 0.94, it becomes 0.97. Okay, so now it is closer to 1. Then next iteration, 0.98. Similarly, you can check all the remaining 7 factors as well. With each iteration, they are coming closer to 1. But to make all of them exactly 1, it will take a lot of time. Okay, so that's what I'm saying. This is why we have the range. Okay, so whenever you have all the factors between 0.9 and 1.1, you can stop, no problem. Okay, moving on. Now we'll discuss cordon counts. The next is specialized counting study is a cordon count. Okay. Now what is the meaning of the word cordon? Can someone give me the meaning of word cordon? You must have heard the phrase, the police has cordoned off the area. What does it mean? The police or the military has cordoned off the area, closed off the area. Okay. So what is the meaning of the word cordon now exactly? Okay, restricted access. Okay, good. Becoming closer. Okay. Anyone else has any idea about this term, cordon? So cordon can mean restricted. It can mean closed. Okay. Anyone else has any idea? Surrounding. Good. Okay. Yeah. Boundary. Yeah, this is the exact term I'm looking for. Thank you, Rani. So a boundary can restrict the area, it can close the area, it is surrounding the area. Okay, so all these answers which you gave earlier, they fit into the term boundary. Okay, so cordon is a boundary. Okay, a cordon is a boundary. So in cordon counts, we create an imaginary boundary around the area of our interest, the area in which we are interested to study the traffic flow. Around that area, we prepare or we lay out imaginary boundary. Okay, virtually, meaning on the map. It's not actually in the field. Okay, why? Because if we put an actual boundary around the area, then nobody will be entering or leaving the area, right? So a cordon count is done into an area of interest, and that area is normally a CBD area. What is CBD? Central Business District. Central Business District, an area which has a lot of activity centers. And we have already discussed activity centers in this chapter, meaning malls, hospitals, airports, things like that. So a CBD or an area of interest for cordon count usually has a number of activity centers, so it is attracting a lot of traffic. The purpose of the cordon count is to find out how many vehicles are attracted towards that area because of activity centers, because of the activities in that area. So what is the accumulation of the vehicles within the cordon? This is the purpose of doing the cordon count, to find out the accumulation of vehicles within the cordon, within the boundary of the area. Okay, and that area is usually area of interest. When you are establishing this imaginary boundary, there are some points which you have to keep in mind. The first point is cover a large area within the boundary so that you are covering the activities of the area. Okay, so for example, if you make your boundary, you lay out your boundary on the map around maybe few streets which are in the center of the area. Okay, now these few streets are part of the area, but the building which is coming in the center is only, let's say, a particular facility. So you are ignoring all the other facilities in that area. Okay, so you are making a boundary around a mall. Okay, so the traffic in that area or around the mall is coming because of lots of other activities. But within the boundary, there's only one facility, which is the mall. Okay, so make the boundary large enough to cover most of the activities in the area, but do not make it so large that you are also including other activities, which can make your planning very difficult. Okay, an important point when you are doing the planning for travelers and traffic is to know the purpose of trip. The purpose of trip tells you at what time the travelers will usually come, for how much time they will park, and so on and so forth. So for example, you make a boundary so large that it has an airport in it, it has a hospital in it as well, it has schools in it as well, and it has shopping area as well. You may see that the traffic is continuing within the area for the entire day and you don't know what to do about it now. Okay, so the area of interest should be a uniform area in which the activities are similar to each other. Okay, so that is these are two rules. First of all, don't make it so small that you are ignoring the activities of the area, and don't make it large enough that you are putting variety of activities in the same boundary. Okay, both these things will make your planning ineffective. Okay, so make it large enough to cover most of the activities in the area, but don't make it so large that you are creating a variety in the activities. Make the cordon, make the boundary or lay out the boundary at the mid-block locations. Okay, where you have straight roads. Don't make it at the intersections. Why? Because at the intersections the cars are turning. Okay, so it will create a problem for you to decide which cars are leaving the area and which cars are entering the area, or which vehicles are leaving and entering the area. Okay, but if you make the boundary at the road segments, then there is no turning possible. So the cars, if they cross, they are left. If they come back, they enter. That's it. So our life will be easier if the cordon or the boundary is crossing at the mid-block locations. Okay, so we are sure that the car has left the area or entered the area. No turnings. Second, or the fourth important point is that if you have an object which is surrounding the area, natural or man-made object, for example, a river or a bridge, which is already there in the field. You are not making it. It's already there in the field. Make your boundary around that object or along that object. Along that object. What is the reason of that? If so, that object is a physical boundary in that for that area, for that part of the area. Okay. So if you make the cordon along that object, then the number of crossing points will be reduced. So for example, you have a river. Okay, half of the area is covered by the river. You make the river part of your boundary. So maybe there is no crossing point across the river. So for half of the area, you don't have to worry about who will cross from here. Okay, you only have to worry about the other half of the area where the crossing is possible. Okay, so if you incorporate the physical boundary with your imaginary boundary, then the number of crossing points will be limited. So instead of making counts at 100 locations, you may be making counts at 20 locations, because from the remaining part of the area, crossing is not possible. There's already a physical restriction there. Okay, so these are the points you keep in mind when you are making the cordon count. Now, can you give me an example of an area which is important enough to do a cordon count in Bahrain? Okay, it generates a lot of traffic. Okay, do you have any example of an area, Sif area? Okay, good. Sif district, education area. Yeah. Okay, good, great. Okay, thank you. Yeah, so these areas are important. You can have it as a cordon count. Now I told you in cordon count, we are trying to find out the accumulation of vehicles in the area. Okay, how do we do the accumulation study for the cordon count? First of all, you start your study at a time where vehicles entering and leaving are almost zero. Where vehicles are entering and leaving the area almost zero. So you start so early that the number of activities in the area have not started yet. The activities in the area have not started yet. So for example, in this case, in this example, you see they have started at 4 a.m. Okay, so from 4 to 5 a.m., no vehicles entered, no vehicles left. So they have placed observers on the entry and exit points of the area, and these observers are recording vehicles entering and leaving. Between 4 to 5 a.m., these observers did not record anything. We had extra observers in the first hour who were roaming or wandering in the area. And these observers found that 250 vehicles are already in the area. And these 250 vehicles are maybe vehicles parked on the side of the road, delivery trucks, garbage trucks, okay? Vehicles which are normally in the area at that time of the day. Okay, so 250 vehicles is our initial accumulation without vehicles entering or leaving, because activities in the area have not started yet. Between 5 and 6 a.m., you see now the observers have recorded 100 vehicles entering and 20 vehicles leaving. Now, how much is the accumulation in the area? 250, which was the initial value, plus 100 which have entered minus 20 which have left. So the accumulation now is 330. Okay. In the next hour, 150 vehicles entered, 40 left. So what's the accumulation? 330, which is the last accumulation, plus 150 minus 40. 40 which have left and 150 which have entered. So in this manner, you can calculate the accumulation of vehicles at the end of every hour of the day. Okay, and you can see as the activities are growing, the accumulation is also increasing. And then in the evening, it starts to decrease. And in the end, you are having a value which is almost equal to the first value. Okay, so if you end your accumulation study at a suitable point, at a suitable time, then the initial value may be equal to the final value, almost equal to the final value. Okay, so this is how you do the accumulation study. You can plot the accumulations on a graph. So on the y-axis you have accumulation, the x-axis you have time, and you can see three curves here, one for total number of vehicles, one for cars only, and one for trucks only. Okay, now this sort of a thing can be done if you feel that a particular type of vehicle is more important for the traffic flow in the area. For example, if somebody asks me to do accumulation study for or a cordon count for education area, then I will definitely count the buses separately and the cars separately, because buses create or have more impact on the traffic flow as compared to cars in this area. They are large, they are more in number, and so on and so forth. Like they are significant in number and so on. Somebody tells me to do a cordon count for the port area. Okay, in that case, I will definitely count number of trucks separately, because again, they are a significant proportion. They have more importance on the traffic flow as compared to others, and so on and so forth. Okay, so in an accumulation study, you may decide that I should count number of cars and the other types of vehicles separately if you feel your planning will require it in the end. If you feel that I need to do planning for trucks and buses separately than other vehicles, you can do it like this. Okay, you can separate the counts for different types of vehicles and you can do the planning accordingly. This is example of a cordon count which was done by students of senior design project in 2018. You can see they started and they did it in diplomatic area. The diplomatic area is also an important area. Okay, there are a lot of traffic because of offices. So they started at 8. Okay, and before 8, obviously, no offices were open at that time. So nobody was entering or leaving. At that time, they had counted 48 vehicles in the area. Okay, and then between 8 to 9, vehicles arrival is this much, departure is this much. This is accumulation. So 48 previous accumulation plus 409 vehicles arrived minus 427 vehicles which departed or left. So this is the accumulation now. Okay, they only did it till 12 p.m., 12 noon, because after that they said, doctor, we are hungry. We cannot continue, otherwise we will fall off on the street. Okay, so they're only till 12 p.m. Okay, but you can continue, like I said, till the end of the day. And this is how you represent the cordon count. So you can see the imaginary boundary with the dotted line, and you can see the dotted line is crossing the roads at mid blocks, at segments. It is not crossing at any intersection. You can see the major roads are represented with bold lines. Okay, and you can see the minor roads are with thin lines. And with at the end of or at each entry and exit point, they are showing the volume for that point. If the volume is coming in, you can see the arrow coming in and going out. And they have also wrote the description in the brackets as well. So this is coming in and this is going out, in and out. Okay, so you can see on the major roads, the numbers are higher and they are for in and out both. On the minor roads, there is one way and the numbers are also smaller. And you have the total of the entire day for the 24 hours, total number of vehicles entering, total number of vehicles leaving, and also have the end accumulation. 1267 is the end accumulation in that area. Okay. Then we have a screen line count. A screen line is similar to a boundary, but it's, the correct meaning of the screen line is like a filter. The correct meaning, the more appropriate meaning is like a filter. So in a screen line count, we are interested in number of trains crossing between two areas. Okay. So now let me summarize. In origin destination counts, we were considering many areas. 3, 4, 5, 6, 7, 8, many areas. In cordon count, we are only considering one area. In a screen line count, we are considering two areas. Okay, so a screen line is an imaginary boundary between the two areas. Imaginary boundary between the two areas. Okay, and again we have the same considerations. Make sure the boundary is crossing at the mid blocks or segments, not at intersections. Between the two areas, if you have an object, for example, a river or a bridge, make the boundary along that object, so a number of crossing points will be minimized. Now, the procedure of screen line count is similar to origin destination study. The whole procedure can be applied to screen line count, but obviously it will be simpler because now we have only two zones. So the example which we did today was for 4 zones, right? If it had been a screen line, it would have been only for 2 zones. The procedure will remain the same. Do the survey of the area, 2 areas, find out how many trips are there, okay, according to your survey, postcard, interview, license plate. Then take the actual volume in the field, prepare origin destination matrix for the 2 zones, and adjust the number of trips using the volumes from the field. So all the things which you have discussed for origin destination applies to the screen line counts as well. The only difference is the matrix is smaller now, only for 2 zones. Okay. Now, so you can see the screen line is a river in this example, and the number of crossing points are very few. Okay, they are still a lot according to my liking, but they are few. Okay, and then you can see the number of crossings plotted according to time. Now there are some things you have to keep in mind because we are only considering 2 areas. You may have external trips as well. What are external trips? People who are coming from outside of the 2 areas. So you're only considering 2 areas, right? People may be coming from a 3rd or a 4th area, which is not part of your screen line. So people who are coming from outside, they are known as external trips. Okay. So when you're doing the survey, you also have to keep or find out the proportion of external trips which are coming from outside other areas. Okay. So the person may come from here and he may come to this area, or he may just cross this area and go somewhere outside. Okay, so this will be known as an external trip. Okay, people came from somewhere and they just crossed the area. This is an external trip. Okay, so you can have external trips if you have chosen the screen line and the areas carefully. Then external trips will be very low. Number of external trips will be very low. Okay, and this is the number of external and internal trips. The black line, the black area, is the number of internal plus external trips which are coming from the survey. And then we have the volume from the field, which is shown by this black line. So obviously the volume is higher than the number of trips which you have taken from the survey. So once you know the proportion of external trips, you apply some factor on the origin destination matrix so that you are only dealing with the number of trips which are internal. Internal meaning only between these 2 areas. Okay, so external trips must be factored out. You find out their percentage or apply some factors, and you exclude them from the origin destination matrix, and this will be done when you are doing the survey. Okay, after the survey. This is a live example, or a real example for a screen line count between Saudi Arabia and Bahrain. Okay, so if somebody asks you to do a screen line count between Saudi Arabia and Bahrain, then your crossing point is King Fahd Causeway. The crossing point between Saudi Arabia and Bahrain is King Fahd Causeway. And what is the screen line between Saudi Arabia and Bahrain? The boundary between Saudi Arabia and Bahrain is the sea, the Arabian Sea, right? It's the Arabian Sea, I believe. So the sea, so if you are doing a screen line count between Saudi Arabia and Bahrain, so the screen line is the sea, the natural boundary which you already have, and the crossing point is King Fahd Causeway. So only one crossing point, your life is very easy. Okay. And even for that crossing point, you don't have to count the vehicles manually. You just do your survey. Okay, you just will focus on the survey because counting is already done on this causeway and the data is published online. If you go to King Fahd Causeway Authority website, you will find data published on daily basis, updated on daily basis. Okay, so they count the number of vehicles, trucks, and everything separately, and they publish it online. Okay, so you can see the graphs which I have taken from the authority website. Okay, and you can see the count of the entire month here. Okay, count which is coming from Saudi Arabia side, count which is coming from Bahrain side, everything is there. So if somebody asks you to do a skill line count between Saudi Arabia and Bahrain, your life will be very easy. Okay, how's an accumulation at the start? As I said, that accumulation is number of vehicles which are already maybe parked in the area, some delivery trucks which are which belong to the stores and malls. So these are this is the accumulation then. Okay, at the start, the accumulation is the vehicles which are already maybe parked in the area. Most of these vehicles will be parked in that area beside the street. Okay, any other questions, confusion, clarification you need? Please go ahead. This is the end of the topic. Cordon at the same entrance and exit point. What do you mean? It depends upon the type of road. You make your cordon at the mid-block location. If it's a two-way road, then you will have entry and exit both. If it's a one-way road, then you will either have entry or exit. It's not in your control. Whether it is for entry or exit, it's not in your control. If it's a two-way road, entry, exit both. If it's one way, only entry or exit. Mahmoud, you are very optimistic. We are taking on-campus exam. Okay, on-campus exam. No Excel. Okay, on-campus exam. Calculator, pen, paper. That's it. Okay. Any other question? Yes, I'll give the formulas. Yes. Required formulas. Formulas which are in the slides, and you also need them in the paper as well. Those formulas. On 28. What is this? It's on 29. Okay, the test is on 29. No, building 15. Test will be in building 15. Okay, anything else? 4 p.m. Start at 4 p.m. Anything else? Okay. If there are no one theory, 4 numericals. One theory, 4 numericals. Any other question? Okay, clear? Okay, then all the best for the test. Have a nice weekend, and we will have a class on Sunday. Okay, Sunday there will be a class. So all the best and have a good time if you can, and see you on Sunday, inshallah. Assalamu alaikum.